Welcome back to Simulation and Prototyping. This is the second project and the tutorials that support the second project. And we're moving from working two-dimensionally and starting to think about just some kind of simple curves and the algorithmic processes related to those, and to starting to move into 3D. And I thought what we might do in terms of working in 3D is to start with a site, to start with topography as a kind of basic element, basic architectural element that we'll work with. And I'm going to introduce a couple of new concepts with this, one being random and how we're going to work with random numbers as a way to kind of quickly generate some things. And then I also want to talk about some simple visualization and representation techniques related to site, and we'll be able to kind of work between those two things. So first I'll start by showing you something similar to what we'll create. What we have here is just a topography, a kind of base cut out of a thicker chunk of material. We can see a topography and contour lines, and so all of these are generated within here, within Grasshopper. And we'll see what's possible with that. I guess with the random numbers, I can also just show there'll be a few things that might be a little funky as I do this, but we can see as I change the slider, which is just changing the random numbers, it's generating new topography. We can also move where the plane is being cut vertically. Change what's happening with this. And so what I'm doing is I'm controlling the X, Y, and Z. And then the contour lines and the cut of this overall topography is being trimmed. The other thing that I will show with this is another branch. And so I'll turn off the visualization of these. And this is just a simple visualization of the height. And so what I'm doing here is just mapping the elevation of each of these kind of sub-panels of the topography, and where it's high, it's green, and where it's lower, it's pink. And so as I generate different topographies here using the random numbers, we'll see we're getting that representation carried out, right? The lowest point is the hot pink, the highest point is the lime green. And so let's start with building some of these, and we'll just work through this as a kind of simple process. So as I've done before, we'll start with new. We'll start with a new Rhino file. We'll do large objects feet. And I'll start with a new Grasshopper file. Just simply new. And I'm going to work in perspective view this time. Last time we just worked in the top view. Okay, so let's start with what we're going to do is we're going to make a patch surface. And so maybe what I can do is just quickly show you what a patch surface can do in Rhino. And what a patch surface will do, it's a very useful surface for some things. It can be a little unwieldy. So what I did is I just made a set of points in plan. I'm just going to kind of randomly move these up and down. I can leave some where they are. And a patch surface will simply, it's like a kind of wet cloth. What it's going to do is it's going to try and build a surface through those points. And sometimes that's easier or harder depending on what we have. So I just typed patch. We can control the division, the U and V spans, but I'm going to leave all of these defaults alone. We'll just preview it, and I'll say OK. So now we can see as we orbit around this, a surface is created, and it's doing its best. It looks like it did a pretty good job here through our points. And so if you want to construct sometimes a topography, begin to push and pull faces, you can use curves and you can use points as a way to generate that surface that patches through things. So we're going to do this, but what I thought might be fun is to introduce an aspect of randomness. And we'll look at the random component. And the reason why I wanted to do this is maybe we want to generate a number of found conditions for the class. And I like to use random as a way to generate a kind of population of design options. And then as a designer, I can kind of pick and choose from those. So let's start with the random. And random is under, let's see where it is. I can never remember where it is because I usually just type it, which I'm about ready to do. And that's the easiest way to find it. So type random. And here's what we get. And if I hold down Control and Alt, we can see where it is. It's under sets and it's under sequence at the very bottom, random. And what random needs is a range, which is actually a domain, and the number of random values, and then a seed value. And what seed is, every time we use a random number, if we give it a different seed value, it will generate a set of different numbers. And this is, I'll talk about this in the lecture in terms of what a random number is and how it's generated. But I'll show you in a second what happens as we make multiples of these. So we'll start with the range. And for the range, we're going to need a domain. So we'll construct domain. And for this, what it's going to be is that the domain, what we're going to do is build X, Y, and Z components that feed into a point. So we're going to make a set of random points. So let's think about our dimension. So for our domain, for X and Y, let's say we go between 0 and 100. And so we know that the domain is already set from 0 to 1. If I mouse over, we can see that to 1. I can right click, set this number. Let's change it to 100. And so we'll work with this idea that our topography is going to go from the origin at 0, 0 to plus 100x and plus 100y. And so we can feed in, that is the range. The number, this is just like the range that we used in the last tutorial, this is the number of steps. And so let's create a slider, and I will go from 1 to 10 to 30. We'll feed this in for the number. And then the seed value, we can use any number of things, and we'll look at this over the course of the semester in terms of what we use for the seed value. We'll keep it simple today. We're going to give it a number between 0, we'll start with 10, and 100. We'll give that to the seed as the seed. I'll create a panel now just so we can see what's generated and how it varies. So what we can see here, because the number of steps or the number of random numbers is set to 10, in Grasshopper it uses 0, it starts at 0, so 0 to 9, it's generating 10 numbers. As I increase this, we'll see that it increases. So if I set this to 20, we'll see it goes from 0 to 19. It gives us those random numbers. We can also see that the random numbers are basically random numbers between 0 and 100, or 0 and 100, and in no particular order. So they're not sorted. And so if we change the seed value, every time that changes, these random numbers are going to change. Okay? And so what we're doing is we're just simply generating for this, one of the components for our set of points. And so I'm going to copy this 3 times because I want x, y, and z for our points. And let's do one thing actually, because we want the x and y, and so let's imagine working x, y, and z. Let's have x and y share the same domain, so we can get rid of that. And we can also share the same number. And since we're doing x, y, and z, we also want to share the same number for z. And so this way we'll have 3 lists that all have the same numbers. Z, let's set this value not to go from 0 to 100, 0 to 100 in plan. Let's set it to go from, say, something like 10 to 20. And so I'll change these values. And I know we're not seeing anything yet, so you have to trust me for a few minutes, but we'll see in a minute what this produces. So what did I say? Let's say from 10 to 20. And this is something that we can come back and change later. Actually, let's add a slider here. So we'll do 1, 10 to 20. And plug that in, and we can copy it and set the maximum to 20. This will allow us to change, with the sliders, to change how much topography difference we have within our topography. Okay, and again, let's see. We'll pull some of our sliders out to the left a little bit so that I'll come back to them and we have the different seed values. Here's the other thing that I'll do, just while we're here and talking about the specifics of how the random numbers work. I just want to show you one quick thing, is that if the seed values are the same, the numbers are the same. And so we want to be careful of having our seed values set to be the same. It's not a huge problem, but everything will kind of line up. And so we just want to kind of play with our 3 seed values to make sure that they're varied. Okay, so let's now have some fun. Let's make a point. And so we can find this under vector and points, and we're going to construct point. Really simply, and we can see as soon as we place this, this is showing us the origin, because this is probably defaulting to 0, 0, 0. So let's feed in x, and look what happened. And so I don't have the grid on my screen, but we can see x, y, and z. So x now, this just generated how many? 20, 21 random numbers for us between, what do we say, 0 and 100. Now if we plug in y, now we just got 15 random points. I can increase this, and it begins to populate. So we have 30 random numbers here, and then I'll add z, and we'll see that those just moved not so randomly because it's using 29 again. We'll randomize this, and we can see that that's also changing. It's a pretty mild topography, but we'll see if this works for us. We can always come back to these sliders in a minute. And so again, I'll talk about the random numbers and why I like them and how I like to use them in the lecture. But for now, what I'm trying to do is just generate some design options, because the project that you have is to show and to represent a large number, like 25 different topographies. And so now we have these points. So the next step, from what I showed you a minute ago, is that we want to make a patch surface through these points. And so I'll kind of slide this over, and we could even maybe be a little cleaner in doing this. Maybe I'll group the sliders. I'll group this in terms of we can label this and call it point construction, because we have kind of distinct things that are happening here. So now let's make a patch surface. And so we want to create a patch surface. We can see it has a number of things coming into it. We can use curves. We're not going to use curves in this instance. We're only going to use points. We have points. We can feed it the points. And we can see it automatically generates a surface. The S is the number of spans. It's set to 20. That's something we can change. We can change the flexibility. And we don't have anything to trim it with yet, and so we'll leave that alone. We can play with the flexibility. I believe this is from 0 to 1. And it's currently set to 1. So let's make a slider from 0 to 0.5 to 1. Set that for flexibility. So now we can see what happens with a few of these parameters. The more flexible it is, the more it will be able to bend through all of the points. And you can see at 0.5, it's missing some of the points. As I get to flexibility 0, that's a flat plane. As I move it all the way back to 1, the plane, well, is even missing a few points. Let's see, I bet we can even increase this max. Let's see how flexible it goes. If we set that to 10, still changing a little bit. In terms of its flexibility. Not much changes from 5, let's say. It'll also change with the number of surface spans, but we'll leave this set to 20 for now. You can see how it looks with yours. Let's now that we've got this, let's go back to our seed values. And we can even change a few other things while we're here. So if we change the seed values, we can see that we're changing, these are the X, these are the Y, and these are the Z. So we have a number of different kind of possible combinations of all of these things that are happening as we randomize these points. We can create more points, remember, or less points. It just depends how articulated we want that surface to be. So this is something that you'll be able to play with. So we've just created this surface, this patch surface, through a number of random points, and you can see that through changing a few of the sliders, you're generating geometry. And so that's good. Let's do now, so I can kind of pause here, actually. We've got this patch surface, really simple definition. Just to recap, we've got 3 random numbers with a range that we're in control of. That's creating a set of points. And remember, because we're feeding a range of random numbers or a list of random numbers into the point, we're creating a certain number of points based on our list. And then we're using that patch surface as a way to create a surface through them. So I can pause here, play with that a little bit, make sure it makes sense. And then what I want to do is to kind of pick up from here and then start to think about how we could represent this in a couple of different ways. So if you need to take a break, you can pause and we'll start up again with different representations of topography.